Hello everyone. So previously we had discussed on the topic activity selection algorithm. Yeah. So today we'll be discussing on the topic interval scheduling or the merging intervals algorithm. Yeah. So let's get into the definition part. Let's see what the definition part states here, right? So the interval scheduling or the merge intervals algorithm here. So this is used to handle the problems involving overlapping intervals. Yeah. So this is mainly this is used to handle the problems involving the overlapping intervals, right? So here it helps merge overlapping time ranges or select non-overlapping intervals efficiently by sorting and comparing the start and end times. Yeah. So again, it helps merge overlapping time ranges or select the non-overlapping intervals efficiently by sorting and comparing the start and end time. Yeah. Let's get into the explanation part here. Right. So now first let's imagine if we have the set of time intervals, right? Like meeting times or the class schedule, anything it might be, or right, meeting times or the class schedule is one of the classic examples. So I have considered this one here. And suppose if we want to combine the overlapping ones into the this one, what do we call into the single interval? So suppose if we want to combine overlapping ones into the single interval, then see, for example, if we have the meetings 1, 3, 2, 4, 6, 8, and 7, 9, right? So this here, see, this one we have to merge because between 1 and 3 is the 2, value 2, right? So this one, these two have to be merged here. And between 6 and 8 comes the 7 here. So these two have to be merged actually, right? So then the merged interval should be 1, 4, right? So 1, 4. So this one we will be considering the larger one at the right side, and here among these two actually we will be considering the smaller one. Yeah. So this one will be 1, 4, and this one again. See, the larger value is 9, and here this one after merging this becomes 6, 9. Yep. Simple. Now let's consider or let's look into the algorithm steps. Yeah. Let's get into the steps. This one algorithm steps part. So here first what we will do, so merging always this one merge intervals or the intervals this one algorithm mostly involve sorting. We know this one. It involves sorting at any cost. So sorting all the intervals, first what we'll do, we'll sort all the intervals by their starting time. So this is starting time and this is based on the this is ending time. First always remember one thing when it comes to merging. So this is starting time. 1 what we have, this is nothing but the starting time. 3 what we have, this is nothing but the end time. Yeah. So we will sort based on the starting time. So this one, 1, 2, 6, as well as the 7, right? So this one, it is already sorted, man. In our case, it is already sorted. See, 1, 2, 6, and 7 starting time we have. So this is already sorted in the ascending order, right? So for this particular example, it is sorted. We don't have to worry, right? Still, we have to sort, keeping in mind all the test cases or all other cases, sorry, not the test cases, we have to sort actually. Yeah. Sort all the intervals by the starting time. Next one is initialize a result list with a first interval. Initialize a result list with a first interval, right? So for each subsequent interval, if it overlaps with the last merged one, then we have to merge them by updating the end time. By updating the end time. Else, we have to add it as a new interval. Here in this case, these two we have to merge because 2 comes between the 1 and 2. Then we have to merge. And 7 comes between the 6 and 8. Then we have to merge. Suppose if we have here 10 this one 9 and 10 after 6 and 8, if we had 9 and 10 then we don't have to merge, right? So 9 comes after 8 actually. 9 comes after 8. So we don't have to merge in that case. Yeah. So that's what. Here if it overlaps with the last merge one, we have to merge them by updating the end time. Updating the end time. Else we have to add it as a new interval. Else we have to add it as a new interval, right? So the resulting list will contain all the merged interval, right? So this is fine. So this algorithm is often used in calendar apps. So we see the calendar apps, right? So usually we make use of this merging intervals apps itself. This algorithm is quite often used in calendar apps, CPU scheduling. So we make use of it in this one CPU scheduling as well, right? So this one I had written before 8 to 10 years. So basically, this is fine, man. This they'll teach you this one within the in the colleges, I believe. Yeah. So this algorithm is quite often used in the calendar apps. This one CPU scheduling, booking systems as well, and time-based data analysis. time based data analysis. Yeah, so this is fine, I believe. Now the exact thing whatever we discussed in the steps of the algorithm or the algorithm steps here, so the same thing will be articulating in the form of code. Yeah, let's start writing the algo. Yep, so I'll just go with a function here, this one, merge intervals. So let me go with a function merge intervals, and let me consider the parameter intervals here. This is fine. So what's the first step here? We have to sort the intervals based on their start time, right? So I'll just consider intervals here. Let me consider intervals dot sort here. This is fine. So let me go with key equals lambda. Let me go with, so why this is not taking here, lambda. Let me type this one instead. Yeah, now this is showing. Wow. So we have to sort based on the start time, right? So I'll just consider here x of 0. Yep. Now let's do one thing. Let's print something for the interactive purpose. I'll just go with here after sorting. So yeah, let me give after sorting here itself. After sorting, what we need to pass here? Let me pass the intervals, right? So this is the intervals that we get after sorting, right? So this is fine. Now let's do one thing. Let's move on with the next step. First step was to sort the intervals based on the start time. Next, let's move on with the step 2 here. We have to initialize the result list, right? So let me consider the variable name merged here. Let me initialize this one to the empty array. Now, let's move on with the iteration part. So this one will be so for the individual interval in intervals actually. Yep. Now within this for loop, so let's move on with the third step here. After initializing the result, let's this one initializing the result list. We are moving on with the we have moved on with the iteration part. So if the merged is empty or no overlap, then we have to append the interval to the merged, right? So I'll just write in this way. See, if not merged or merged of this one -1 as well as the 1 here is empty or no overlap we are considering, right? Here in this case, less than interval of 0, individual interval of 0, then what we need to do here, let's append the interval to the merged, right? So I'll just go with a merged dot append here. Yep, what we need to pass here, interval. Yeah, this is fine. Next, let's print something for the interactive purpose here. I'll just go with the print. Let me start with the O here. On sorry, F. Basically, we'll be making use of the string interpolation here. This is fine. I'll just go with no overlap. Then I'll just go with the adding. So let me go with the interval here. This is fine. Let me go with a merged list. Let me go with a merged list. So this is fine. Yep. Let me pass merged here, right? So let me pass merged here. This is fine. Else, let me go with else here. Else, uh, then what we need to do? So here, overlapping, suppose if the overlapping intervals exist, then we have to merge them, right? So I'll just keep here merged of -1, 1. So let me go with the, or let me assign this one to the max of merged of again same -1, 1 along with the interval of 1. So let me give here interval of 1. Yep. So this is fine. Next step again, let me print something for the interactive purpose here. Let's print something for the interactive purpose. Start with the when. So we'll be going with the string, this one interpolation here. I'll just go with overlapping. So let me pass interval here. So this one, let me pass the interval. This is fine. Let me go with something. I have done something wrong. I don't know what. Yep, this is fine. Oh, I've missed this one. Yeah. Let me give here merging. Double inverted comma I missed actually. So this is fine. So merging. Merging. Let me give in this way. The merge list that we need to get here, right? So merge list. Let me pass the merged here. Merged is the variable name that we have considered, right? So let me pass the variable name merged here. So this is fine. Finally, what we need the merge list itself, right? So let me return the, sorry, merged here. I'll just keep merged. So this is fine. One of the simplest algorithms, man. Yeah. So basically this uses greedy. Right. So now let me get the example usage from the Google. So this is it for the algo. Algo is simple. We have discussed this one step by step. Yeah. So now let me get the example usage from the Google, man. Just give me a second here. I'll just come here. Let me paste it over here. Right. So intervals I have considered here, right? Input intervals, right? So now we are printing something for the this one interactive purpose. Original intervals, and we are passing the intervals here. First, we are printing the original intervals. Then result we are passing this one. Actually, we are calling the function merge intervals here along with the interval input. So this one intervals, right? So finally, we have to get the output result. This one, final merged intervals, right, along with the result. After merging this one, we have to get the merged intervals, right, in the form of result. Yeah. So here we have considered the same examples 1, 3, 2, 4. So output that we need to get here is this one 1, 4 and 6, 9. Yeah. So just give me a second here. So yeah, the output that we need to get here is 1469. Initially, we are displaying the this one itself 1324. This one 68 and the 79. The same example I had considered. I thought of taking different example. This is fine. Uh, we have to get this, these two gets merged actually for this one 1, 4, and these two gets merged actually for the 6, 9. After merging, we get 1, 4 and 6, 9. Yeah. So this is fine. This is the output that we need to get, and we have already discussed this one. Yep. So see, let me explain you once again actually the output part here. See, just so that we understand this one clearly. So the original list is this one. Yeah, this one. So 1 3 starts, so we add this one to the merged initially. 1 3 starts, right? So this is the starting interval. We'll be adding this one to the merged actually accordingly with the algorithm. Yep. So now 2 4 overlaps with 1 3 actually. Yeah, 2 comes between 1 and 3, right? So 2 4 overlaps here. So what we will do with 1 3, so we will merge this one to the 1 4. So we'll merge these two actually, and the result will lead to 1 4 actually. Now from these two we have the this one 1 4, right? So this is fine. Next we'll do the same thing for the this one, what do we call 6 8 and 7 9. See, 6 8 doesn't overlap with the previous one. 6 8 doesn't overlap with the 1 4 actually. Yeah, this is fine. Now we will be adding this one to the merged again. Yep. Now we have 7 9. 7 9, what it does, 7 9 overlaps with the 6 8. See the previous one. So 7 comes between 6 and 8, right? So this overlaps. Yep. So with the 6 8. So we will be merging that to the 6 9. We will be merging that one to the 6 9. Right. So how we will merge basically? So we merging means these two intervals. So this one we will take the minimum of this one starting, and we will take the maximum of the ending actually. Yeah, just remember this one minimum of the start time and ending of the this one maximum of the end time actually. Yeah, so this one will be 6 9. Yep, 6 9. So next we will be after merging it would be 6 9. So we got 1 4 and 6 9. After merging, the final result has to be 1 4 and 6 9. Yeah, so the output that we need to get here is, first we are printing the original intervals entire thing we are printing. So this one, see, this one we have to get. Then after sorting we have to get the same thing 1 2, this one 1 3 2 4 6 8 7 9. It is already sorted here in this case. For the example that we considered, this is already sorted, so we are printing this one. This is also fine. Overlapping 2 4 merging merge list. So this one 1 4 we have to consider first overlapped one. Then no overlap 1 4 and 6 8. This one doesn't overlap, so we are printing that one as well. Then overlapping 7 9, 7 9 is getting overlapped. What are the things that are getting overlapped and non-overlap? Non What are the things that are not overlapping? Those things also we are printing, right? So here overlapping 2 4 4, this one merge list has to be 1 4. Then no overlap adding 6 8 merge list, no overlap. Then overlapping again 7 9 overlaps, we have to get 1 4 and 6 9. Finally we are printing this one final merged intervals along with the result, nothing but 1 4 and 6 9. So this is the output that we need to get here, right? So let's run the code now. As we have complete idea on the algo, let's run the code now. So I'll just come here, control J, Python followed by the file name dot py. So see here. Uh, what the heck, bro? 1 second. Even though it has to be not algo dot algo py, it has to be all. 1 second. This one, let me give here algo dot py. So this one also I believe. So this is fine actually. Yeah. No, actually this one also we have to change. There is no dot here. Algo dot java. So this is fine. Yep. So 1 second. So let me clear screen here. Let me run this one again. So yeah, original intervals. So that was also fine. That is fine. So see here, original intervals 1, 3, 2, 4, 6, 8, and 7, 9. The same original intervals. The this one we are considering, right? So we are printing the same thing. After sorting, in this case, for this particular example, we are sorting based on the start time, right? So for this example, it is already sorted. See here, 1, 2, 6, and 7. We are this one. We are sorting based on the start time again, right? So we are getting the same thing, which is absolutely correct. No overlap. If there is so first we will consider 1 comma 3. So there is no overlap, so we'll just consider 1 comma 3 directly. Then we'll consider overlapping. So this one 2 comma 4 overlaps with 1 comma 3. So the final output we need to get after overlapping this one, after merging this one, we have to get 1 comma 4. We have discussed this one just now. So see here, merge list 1 comma 4. Next, we have 6 comma 8. 6 comma 8, after merging we will compare this one with a 1 comma 4. Does the 6 comma 8 merge with 1 comma 4? No. So this is no overlap. See here, we are getting no overlap. 1 comma 4, 6 comma 8. Finally, we have to this one check 7 comma 9. 7 comma 9 with the 6 comma 8. Yes, 7 comes between the 6 and 7. 6 and 8. Sorry, 7. So 7 overlaps here. In this case, overlapping 7 comma 9. Merging merge list this one 1 comma 4 and 6 comma 9. So this is correct. This is absolutely correct, right? So final merged intervals 1 comma 4 and 6 comma 9. This one, yeah. So this one we have to get. So we are getting the desired output, which is absolutely correct, right? So this is fine. Yep. So we are done with the algorithm part. We are done with the algorithm part. So this is it for the interval. This one interval scheduling or merging intervals algorithm or problem. Yeah. So now let me summarize whatever we have learned so far, so that we shouldn't forget certain things, or these things are very important. Just try to remember this one, these 3 to 4 points. Yeah. So first one, what is the purpose of this particular algorithm? So basically, we can combine or handle overlapping intervals efficiently, right? We can combine this one or handle overlapping intervals efficiently, right? OI, that is override efficiently, right? Overlapping intervals efficiently. Yep. So the second point here would be time complexity would lead to big of n log n here. The time complexity would lead to big of n log n due to the sorting. Just remember this one. Yeah. Due to sorting, the time complexity would lead to big of n log n. And what would be the space complexity? The space complexity would lead to big of n for the result list. For the result list, the space complexity would lead to big of n, right? So common use cases. Let's discuss the use cases as well. Some of the common use cases are here. So this one is used in meeting scheduling, as discussed earlier. This one, meeting scheduling, CPU job scheduling, actually CPU job scheduling. So this is also one of the use cases. And the third one is calendar merging. So this one we had discussed this one earlier, right? So meeting scheduling, CPU job scheduling, calendar merging, as well as the event timeline simplification. Sorry, event timeline simplification. So these are some of the important use cases. Yeah, you can just consider this one as the fourth point. Yeah. So these are the points that I wanted to discuss with you guys. These are some of the points I found it very helpful or very important, basically. Yeah. So this is it for the interval scheduling or merging intervals algorithm. Yeah. So next we will be discussing on the topic job sequencing algorithm or the problem. For now, this is it. Thanks for watching, guys.